vertical flatboard of cross-sectional area A moves in still air at constant speed v, as shown in the figure. Consider the relative motion of board and air molecules under this condition. Assume that the air molecules collide with the surface of board perpendicularly and after colliding bounce back in the opposite direction with the same speed v with respect to the board. Part 1. If m is the mass of an air molecule, write down an expression for the change in momentum of the molecule. We can consider directions of initial velocity and final velocity. This one is the board. Air molecule is moving with v velocity and after the collision it is moving with v velocity in opposite direction. Then I will get change of momentum in this direction. It should be final momentum minus initial momentum. But initial momentum is in opposite direction. We have considered this direction as plus. Therefore, it should be minus mv. Then we can simplify it and we can obtain 2 mv is the change of momentum. Then part 2, considering the number of air molecules colliding with the board per unit time or otherwise, so that the magnitude of force exerted on the board by air can be given by F equals 2a dv squared, where d is the density of air. The force is known as drag force. Now we can consider the air volume collided with the board within 1 second. We know that air molecules are moving v distance for 1 second. Then the air volume collided with the board within 1 second should be a cuboid like this. Length of the cuboid should be equal to the velocity of air molecule. Then we can write force is change of momentum divided by time. But now we have to consider the change of momentum only for one air molecule. Therefore, we have to use total air mass in this cuboid to find the total force, net force. Then we can substitute mass equals volume into density. This cross-sectional area is given as A. Then we can write volume is A into length, area into length of this cuboid is V. Then we can substitute 2AVD times V. Now we have considered air mass per 1 second, therefore time should be 1. Then we can obtain 2AdV squared is the force on the corresponding board. Then part B, the drag force Fd on an object moving in a fluid depend on the shape of the object. A more accurate expression for Fd can be given as Fd equals KAdV squared, where K is a constant which depends on the shape of the object. Drag force plays an important role in the design of the external shape of a vehicle. Consider a motor vehicle moving in still air on a flat road with constant speed v. Take K value as 0.2, A 2 square meters for the motor vehicle, and D value is 1.3. write down an expression for the power needed to overcome drag force Fd. We can write work done is force into distance. Then work done against the drag force is drag force into distance. Then work done against the drag force into distance. Now I will divide both sides by time. Work done divided by time is the power against to drag force. It is given as P. Drag force into distance divided by time means velocity. Velocity is V. Part 2. Calculate the power when the motor vehicle is moving with speed 90 km per hour. 90 km per hour value is given as 25 meters per second. Then we can substitute to the equation power equals Fd into V. We can substitute drag force by using the given equation K A dV squared multiplied by V. Then we have to substitute values. K value is 0.2, area 2, density 1.3, velocity 25 cube. We can multiply it and we can obtain the value 8,125 watt. It is the power. In part 3, calculate the power when the motor vehicle, part 3 is the power needed to overcome other external frictional forces acting on the motor vehicle is constant and it is 6 kilowatt. What should be the total power supplied by the drive wheels of the motor vehicle in order to maintain constant speed 90 kilometers per hour? We have found the power needed to do the work done against drag force 8,125 watt. We have to add the remaining power value 6 kilowatt. It is given in the question. 6 kilowatt means 6,000 watt. 5, 2, 1, 14,125 watt. In part 4, if the speed of motor vehicle has been increased from 90 to 125, calculate the additional power required to maintain the speed of the motor vehicle at that value. Now we have to find the new power required to work done against the drag force. Drag force is Ka V squared multiplied by Ka dV squared multiplied by velocity. It is the power against the drag force. K value 0.2, A2, G value 1.3. Velocity now 35 to the power 3. We can simplify it and we can obtain 22,295 watts. 22,295 watts. We can consider the power needed to overcome the external friction is constant. Therefore, we can consider change of power, difference of power. 22,295 drag force is the power against the drag force in new condition. Previous one 8,125. We can subtract it and get the answer 14,170 watt. We have considered that the work done or power against the remaining part of friction is constant. Part 5. The motor vehicle shines at constant speed 90 km per hour on a 90 km per hour on a road of slope 3 degrees. Calculate additional power that should be supplied by the drive vehicle. Consider that the mass of motor vehicle is 1200. Now there is another required power against the gravity. It means against the potential energy. Therefore, we can get new power should be mgh divided by 2. It is the additional power. mgh divided by time. Additional power required to work done against the potential. Now, they have given angle is 3 degrees. We have to find this height for 1 second. Height for 1 second. Therefore, we can substitute v value as the distance moved by the vehicle along the slope. When considering v value for the distance, we can obtain height per 1 second. V value means distance per 1 second. Then in mass of the vehicle 1200 G10, we can obtain h value v sin 3. Now we have given sin 3 value. We have to substitute 1200 into 10, 12,000. V is the velocity. It is 90 kilometers per hour, 25 meters per second. Sin 3 value is 0.05. We can multiply it and we can obtain the answer 15,000 watt. It is the additional power required to do the work done against the potential energy. Then part 3. Consider a motor vehicle moving on a flat road described in V3 above. V3 means it is 90 kilometers per hour. Consider that the energy released by burning 1 liter of petrol is 4 into 10 to the power 7 joules and only 15% of this energy is used to drive the vehicle. Under following conditions, calculate the fuel efficiency of the motor vehicle in kilometers per liter. Part 1, when it is moving in still air. Part 2, when it is moving opposite direction wind flow, constant speed 36 kilometers per hour. At the still air, we can consider that required power is this one, 14,125 watt. We have to calculate fuel efficiency. Fuel efficiency means kilometers per liter value. We know that energy given by 1 liter of fuel (4 into 10 to the power 7), but we can get effectively 15% of this one. It is given in the question. Then we can simplify it. 10 to the power 5, 4 times 15, 16 to 10 to the power 5 means 16 to 10 to the power 6 joules. It is the effective energy released by 1 liter of fuel. Now, I will equal this value to the energy used by the vehicle. This value is power. Power means energy per 1 second. Then 14,125 joules per second is required by the vehicle. Then I will multiply by time to required energy to find the required energy within t for the t time. It should be equal to 6 into 10 to the power 6. And we can find the time, moving time of the vehicle with 1 liter of petrol. 6 into 10 to the power 6 divided by 14,125. 424.8 seconds per liter. Now I will use S equals ut to find the distance moved by the vehicle. We have to find S value. U is the velocity, 25 meters per second. 25 into time is this value. This value is meters per liter. But we have to get it in kilometers per liter. Therefore, I will divide it by 10 to the power 3. Kilometers per liter. Then we can obtain the answer 10.6 kilometers per liter. Then second one, when it is moving in opposite direction to a wind at constant speed 36. 36 means 10 meters per second. When moving the vehicle against a wind, we have to consider relative velocity of wind relative to the vehicle. It should be 35. Therefore, now required power. We can write power by using the derived equation K A dV squared multiplied by V. K value 0.2, area 2, V 1.3. Now velocity of vehicle relative to the wind is 35. Then 35 to the power 2 multiplied by 35 means 35 to the power 3. We have to consider 6,000 watt. It is the power against the friction. And we can obtain an answer 21,925 watt. Then we can use this method to find the fuel efficiency. Now I will get power into time is the work done. It should be equal to energy, effective energy released by 1 petrol liter, 6 into 10 to the power 6. Now power is 21,925 into time equals 6 into 10 to the power 6. I will consider new time as t dash. Then we can find t dash 6 into 10 to the power 6 divided by 21,925. And now I will use S equals ut to find the distance traveled by the vehicle. We have to find S. Velocity is 25 kilometers per hour. It is not changing. We have to get relative velocity when only getting the drag force. Velocity 25. We have to find the time. We have to substitute time. 6 into 10 to the power 6 divided by 21,925. This one is meters per liter. Then we have to divide it by 1000 to convert kilometers per liter. Simplify and then we can obtain 6.8 kilometers per liter. Now we can identify if there is a wind against the motion, the fuel efficiency is decreasing.